All right, hello everybody. This video we'll talk about number 6 on chapter 2. So number 6, you have this building and Allison is over here 20 feet away from the side of the building and she is going 10 feet per second north. So we'll put a thing here. So the distance she goes is velocity times time, which is 10t. And we just know that'll be in feet. Okay, so her distance she goes that way is 10t, and that's in feet, because distance is 10 feet per second times seconds gives us feet. And Adrian, meanwhile, is going that way at 8 feet per second, so Adrian's distance is 8t. Okay, so the distance there is 8t. And where are the two girls located after 2 seconds? So in 2 seconds, t is 2. The distance here is 20. So we have a distance here. If I just draw a little triangle here, we have 20 here, which is 10t, and 16 here. And so they are 20 up and 16 over. I guess that's pretty easy. So they just want you to see these formulas here. After 2 seconds, Adrian is 16 feet over this way, and Allison is 20 feet up. Now, we use that for the next one. What will this slack in the bungee cord? When will it be used up? They tell us the bungee cord is 30 feet long. So the bungee cord is 30 feet long. Is this length here 30? Are they 30 feet apart? So the bungee cord is stretching. We want to know how far apart they are here when this is 16 and 20. So the distance they are apart, right, it's not the hypotenuse of the triangle, so it's just the Pythagorean theorem. The distance they're apart is the square root of 20 squared plus 16 squared. And if you do that, I got about 25.6, so about 25.6 feet. And that is not 30 feet, so the bungee cord is not stretched. Okay, now it gets trickier. So what time will the bungee cord actually be stretched? Okay, so it's not quite there. After 2 seconds, it's at 25, not 30. So we can guess it's not going to be much longer. 3 seconds, 4 seconds, because it's getting stretched out pretty good. So then we know that the distance, let's just try to draw a bigger triangle now. So here's Allison's, here's this. This distance here is 10t. This is 8t. We want it to be 30. What t makes that 30, right? What time makes that 30? So this squared plus that squared equals that squared. So 10t squared plus 8t squared equals 30 squared. Pythagorean theorem again. Okay, that's not so bad. We do all that out. Be really careful. Remember, this is 10t times 10t, so that's 100. You square each one, 100t squared. So we have 100t squared plus 64t squared equals 900. That's 164t squared equals 900. T squared is 900 divided by 164, which who knows what that is. And so t then is the square root of that. Okay, so you can get that number, and then t then is the square root of whatever 900 over 164 is. And I got, when I did that, about 2.34 seconds. 2.34 seconds, which makes sense. We know it's not 2 seconds. We got that was like, almost there, almost 25 feet, almost 30 feet. It's like 25 something. And at 2.34 seconds. Okay, so that works. So then it'll be stretched. Okay, then the last part says, when will the bungee cord first reach the corner of the building? Okay, when will the bungee cord first reach the corner of the building for part D? And that's probably the trickiest part. So I'm going to erase all this. And they give you a hint. They say to use similar triangles. So what does that mean? So we want to know when it looks something like, I don't know, something like this. because we know Allison's going faster, 10t, and Adrian's going slower, so this side is bigger. So I'm trying to do it to scale. This distance here is 10t all the way is 10t, right? That's how far Allison goes. And then Adrian goes this distance here, which is, do it the same way I did it up there. That is 8t, the whole triangle. Okay, so that is one triangle. We have a big triangle here. One side is 10t, one side is 8t. Now let's draw a smaller triangle. And there's two we can draw. We can draw this one. And it is going to be a similar triangle, as you learned in geometry and stuff, because this angle is the same. All the angles are the same, right? All the angles are the same. And therefore, they are similar triangles. The ratios of the same sides are the same. Now, we have two possibilities. I could also do this one. Okay, it's also a similar triangle. All the angles are the same as that, and they're the same as the big one. Okay, let me draw the big one in black here. So we have this big one here. Okay, so that's the big one. So the big black one is the same as this blue one, same as that blue one there. Make it blue all the way around. Something like that. So we can use the big black one and either one of the blue ones. So let's use this blue one. Just the back of it. This side is 30. This side down here is 8t minus 20, right? Because this is 20 right here. We said, tell us this is 20. This is the tricky part. This is 20. So this part here is the big distance, 8t minus 20 is what we have left. So right here is 8t minus 20. That was the tricky part. We have to get the sides. This side's easy. We know it's 30. They tell us this side is all of it, 8t minus this distance here, minus 20. Now we can set up a ratio using similar triangles. This is what they talk about. Doesn't matter which one we start with, but we have to keep them the same. So let's go 10t. Let's just start with this one. We could have gone the other way, 8t, but just chose this one. 10t is to 8t. So 10t is to 8t. So long side is to this side. As 30, the up and down one, we got to keep the same. 10t is 30 are the same. So as 30 is to 8t minus 20. As 30 is to 8t minus 20. Now, we just solved for t. What t makes that true? And let's simplify first. 10t minus divided by 8t, the t's cancel. A t divided by t, the t's cancel. And 10 divided by 8 is 1 with 2/8 left over, which is 1/4, which is 1.25. So on this side, we just have 1.25. So 1.25 equals 30 divided by 8t minus 20. Let's simplify this side. We can divide everything over here by 2. Divide 30 by 2, we get 15. That's the best we can do. Divide 8 by 2, we get 4. Divide 20 by 2, we get 10. Okay, just makes it easier. Now, cross multiply. 1.25 times 4t minus 10 equals 15. 1 1/4 of 4 is 5. Check that out. Yeah, 4 times 1.25 is 5. 5t minus 10 times 1.25 is 12.5 equals 15. Put the 12.5 over here. 5t equals 15 plus 12.5 is 27.5, or t is 27.5 divided by 5, divide both sides by 5. Let's see, that would be 5.5. 5.5 when we're dealing with seconds, so it would be 5.5 seconds. So, in 5.5 seconds, the corner of the building is going to get the bungee cord, it's going to get all messed up. Now, we could have used this triangle also. So let's just set it up, and then you can verify. We still get 5.5 seconds. So then we'd say this side is to this side as 10t is to 8t, right? So we still go 10t is to 8t, 10t is to 8t as this, which we know is 20, is to this, and this is like we did before, since this side here is 30, this little part here is the whole thing, 10t minus 30. The big thing minus this little part here, right? Because that part's 30. So we'd say 10t is to 8t as this side, 10t minus 30 is to 20. And you should get the exact same thing. You should get 5.5 seconds because either little triangle works. All right, that's how you use similar triangles to solve some cool problems. It's a common trick. We do it in calculus a lot. It's just a really easy way sometimes to set up a relationship so you can solve some cool math problems. Excellent. Thank you for listening.